Hello, matey peeps, and welcome to this lesson today on describing chance. Yeah, I don't know what's going on. It's been a long day. And so, this video aligns with the Year 7 Essential Mathematics Series Victorian Curriculum from Cambridge and is there to help me support my teaching. But why not have it out there in the wild for those who might help and wish help? So, describing chance. By the end of this lesson, hopefully you will understand what I mean by certain, unlikely, impossible, and likely, which are words very much used in 5 and 6, but in Year 7, 8, and onwards, probably not so much, because we tend to use the idea of probabilities as fractions and decimals and percentages. And if you're not sure about fractions, decimals, and percentages, then I've got videos on that as well. We're going to use words to describe these outcomes of chance events. We're going to understand where they might fit on a continuum. Oh, I like that word. And understand how these words might be used to describe probability events. All right, so let's have a flashback to Year 5 and 6. Now, obviously, if you're already in Year 6, that's going to be a flash forward, maybe. We use lots and lots of different words out there to try and help us describe the chance of something happening. All right, so for example, what is the chance of me looking out my window at the moment and seeing a horse fly? Seeing a horse fly, I imagine, is going to be impossible, all right? Now, I know you're probably looking at this one here and going, but doesn't that say impossible? Well, no, someone was trying to be clever by crossing out the impossible to make it possible. What is going to be possible? Hopefully, what can I think of that's going to be possible? That the sun will come up tomorrow, all right? At some point during the day, we will have light, even if I can't see it. And there are other words to describe, maybe certain, maybe unlikely, very likely, and one that we use possibly ever such a lot is this even chance. Now, the great thing about these words are they can be placed on a line. What do you mean a line? Like a number line. So imagining we have a number line that goes from this start to the end. Now, we probably already have been talking about the idea of probabilities in terms of percentages, right? Or we've got a basic understanding that we could probably put the numbers 0% all the way up to 100%, which would suggest that in the middle is 50%, here would be about 25%, and here would be 75%. Well, what does 0% actually mean? If we have a probability of something having a 0% chance, then I'm pretty sure that that's going to be impossible. So I'm going to write impossible here. And on the other end of the scale, well, we could write the word possible, you know, for something's 100%, because it's possible, but that doesn't sound strong enough to me. So why don't we actually say certain? Right? If something is certainly going to happen, then I'm pretty sure it's 100%. 50%, most people go about, you know, when we throw a coin up, there's a 50% chance, or more likely, even chance that something's going to happen. Well, what's going to fit here? Around 25 and 75%. And these are just numbers that we've put on the number line to sort of break it up into quarters. Well, I suppose we could possibly, see what I did there, put the word unlikely and put the word likely here. Now, there are actually lots of different words that could stand for likely and unlikely, and I'm sure you could sit and think of, you know, lots of them now. But generally speaking, in Years 5 and 6, yes, we use these type of words to describe probabilities. As we move through Year 7, we're going to start using these percentages and fractions and decimals to describe percentages. So it's just good to be able to have a working understanding. So, for example, you know, and these questions have been taken from the Year 7 Cambridge Essential Mathematics textbook. No copyright was meant to be infringed. We might be asking questions and have to decide if something is likely. So what if the question says, given some various options and certain words, we have to describe the likelihood of them happening. So classify, there's a good word. Each of the following statements is either true or false. It is likely that children will go to school next year. Well, I think that's actually true. I mean, obviously you're sitting there going, yeah, but not if this happens and this happens and this might happen. Yeah, I know, but assuming all continues the way it is likely that children will go to school. So there's A done. It is an even chance for a fair coin to display heads. Now, here's an interesting word, fair coin. What is a fair coin? Well, in this situation, how many different outcomes are there for a coin? And by an outcome, I mean how many different things can happen. If we think about it, we have a head or we can get a tail. Now, for something to be fair, there has to be an equally likely chance of the head and the tail happening. And generally speaking, we would say the probability of a head happening and the probability of tail happening is a half and a half. We would hope they would be about the same. The opposite words to fair, and this is a really important word, is the word biased. So generally speaking, like in English, we can use that to say that someone is biased in their opinion, right? That means they're sort of more in favor of one thing than another. And I suppose that's also true for probability. If it's biased, it might be more in favor. So using the coin example again, and we have head and tail, what if the probability of getting a head was 3/4 and the probability of getting a tail was 1/4? Well, they're no longer fair. It would seem that it's more likely to be a head than a tail, otherwise known as biased. But back to the question. It is an even chance for a fair coin to display heads. I would say that's true as well. Rolling a 3 on a 6-sided die, and here's an example of a 6-sided die, and getting heads on a coin are equally likely. Whoa. Right, okay, so rolling a 3 on a 6-sided die. How many 3s are there on that 6-sided die? Well, there is 1 3 out of 6 possible outcomes. Ooh, and what about getting a head on a coin? Well, we've just decided that there is 1 head out of 2 possible outcomes. Are they the same? I should not think so. And notice that when we want to say not the same, we can put an equals with the line through it. So in that case, I would say false. And it is certain, ooh, that's a strong word, that two randomly chosen odd numbers will add to an even number. And again, you can spend all day choosing random odd numbers. Let's do 1 plus 3 is 4. 5 plus 9 is 14. 11 plus 27 is 38. Are all of these odd? Are all of those even? Yes, they are. And as such, it is actually certain, right? You are never going to be in a situation where you can find any odd number that won't add to an even number. So those are great questions, and they sort of build. I really like this question C, this part C, which has started to get us to think about, expressing probabilities in different ways. So, we have to know about things about die. So what do we know about things like die and dice? Firstly, they have the numbers 1, 2, 3, 4, 5, and 6. Hopefully, they will be fair, which means that each outcome is equally likely to happen. All right. Whether you know this or not, the opposite sides on a die add to 6. No, they don't. They add to 7. Oops, awkward. They can't add to 6. That would be silly because that would be a 0 on a die. All right. So the opposite ends add to 7. What about cards? Now, it's such a shame that guys don't play cards anymore. What's gone wrong? Patience and solitaire and stuff. But there's lots of things you need to know about packs of cards. For example, they have what we call 4 suits. Right? They're split up into 4 different variations of cards. Those 4 suits are hearts. They are diamonds. They are spades. And they are clubs. And in amongst that, we know that hearts and diamonds are both red in colour and spades and clubs are black in colour. Each suit, so each one of hearts, diamonds, spades and clubs, has the numbers 2, 3, 4, 5, 6, 7, 8, 9 and 10. And then they have an ace, a jack, a queen and a king. Now, these cards here are called picture cards. Why? Because they have pictures on them. Random? Yes, I know. Right? And these are obviously called number cards. So if we go back to the information that we now know, if hearts and diamonds are both reds, then half of them are red and half of the cards are black. How many cards are there in total in a pack of cards? There are 52 cards in total. which would suggest that hearts have 13 cards, diamonds have 13, spades and clubs each have 13 each. So all of this information comes in really, really useful. How? Well, again, if we consider a fair six-sided die with a number 1 to 6 on it, would the following be true or false? Rolling a 3 is unlikely. Well, if we look at the idea of our probability scale where we have 0 and we have 100 and we have, what was that, 50% there? We said unlikely was going to be around the bottom half. Well, rolling a 3, how many 3s are there? Well, there is 1 3 out of 6. Well, 1 out of 6 is actually less than 50%, all right? 1 out of 6 is less than a half. So if we write half here, so that would suggest to me that I think rolling a 3 is unlikely is true. If we were looking at this in terms of probability. What about rolling a 5 is likely? Rolling a 5 is likely. Again, I would say that was untrue, all right, or false. Why? Because a 5 is going to have the same probability, 1 out of 6. Rolling a 4 and a 5 are equally likely events. Right, well, rolling a 4, there's 1 4 out of 6. Rolling a 5, there's 1 5 out of 6. They are exactly the same, and it says equally likely. So that is true. Rolling an even number is likely. Oh, again, this gets tricky, doesn't it? Because what does the word likely mean? Well, how many even numbers are there? There's 3 out of 6. Which means there is a half chance. Well, to me, I would say that was an even chance, not necessarily likely. See, this is hard. So, well, what would I put? Rolling an even number is likely. I'd say false. It's an even chance. Is there an even chance of rolling an odd number? Well, how many odd numbers are there? There's 3 odd numbers out of 6, which suggests half, and there is an even chance. And is there an even chance of rolling a multiple of 3? Wow, multiple of 3. How many, what's a multiple of 3? Well, that's like saying the 3 times table. 3, 6, 9, 12. Well, we know the highest number on a die is 6. How many are multiples of 3? There's 2 of them out of 6 in total, which when we cancel down becomes 1 over 3. Is that an even chance? Nope, because 1/3 is less than a half. And so that is false. The other thing you need to be able to work out is the idea of spinners, all right, and sections being the same size. Now, in this situation here, if we see the red, the green, and the blue, all of those pie slices, if we think of this as a pizza, and I'm there with 2 of my friends, would I be happy that we were all getting equally the right size or the same size? Absolutely. They're all seemingly the same area. All right, the same size, and so in this case I would say it was equally likely of getting any of those colors. Right, there's an equal chance because the red, the blue and the green are the same size. But in this situation here, what do we notice? The 6 is actually bigger. And if that was me going to Pizza Hut, that's the slice I would have, thank you very much. My 4 other friends can just sit there and eat less. All right, now the 6 is bigger, so in which case I would say it was more likely to land on a 6. But what do you notice about the 1, 2, 3, and 4? Well, they are all the same size. So again, it's interesting to note that the numbers 1, 2, 3, and 4 are all equally likely. Now that's not true of the whole pie slice because we've got this number 6 here that's already bigger. But the thing to do is we should always ask ourselves the question, is there an equal chance of getting something, and is it fair? All right, so that has pretty much completed the lesson on describing chance. Hopefully you learned something. All right, again, this is a quick lesson to actually go through. Just make sure you know what the words. I look forward to seeing you next time.